Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll conclude our discussion of the Dependency Injection design pattern and focusing on ways for managing dependencies, and in particular the Google Guice library for doing so. As your application scales, there are more and more objects, and more objects depend on each other, and wiring all these objects together can be really cumbersome. As you can imagine, you've been applying the dependency injection pattern, and so now you have smaller objects that then, or at least smaller constructors, that just take all the dependencies, sign them off into final fields, but then something's going to wire all that together, and you end up with a big piece of code that creates all the objects and puts them all together. And as a result, it's kind of hard to find all the places where things are used. And so if you want to change an implementation of a class, it can be kind of hard to find where everything is and how everything fits together. And this is not a new problem. It's something that people have been facing for a long time. And a couple of the solutions that people came up with are design patterns like the factory pattern, where you have one object that creates another kind of object. And so the way it was usually implemented in Java is that there was a static method out there that went off and created an instance of a class. Actually, we saw some of these in like the calendar API, right? There was also a design pattern called the Singleton Pattern. So the whole idea is that you had one and only one instance of a class in your program. And when some code wanted that instance, they would go off and call a factory. They would go say, hey, get me the one instance of that. Now, often, again, in a static method. Unfortunately, these patterns were difficult to get right. There was a lot of boilerplate involved. It looked awkward after a while. It felt less and less object-oriented. Implementing singletons correctly is surprisingly tricky, especially in concurrent application where you've got multiple threads that all want to access the same object. And also, if you wanted to have maybe objects that were pooled or cached, something like database connections or the results of expensive operations, these patterns didn't provide a lot of help there. So enter Google Guice. Guice is a framework that is good at configuring and injecting dependencies into Java classes. So get it injecting like the steroids and the Lance Armstrong and all that. Yeah, okay, whatever. And the nice thing about Google Guice is that it's language based, meaning that you leverage annotations to provide type safety. It's got a Java API that you use to get objects, and this is in contrast to sort of traditional Spring dependency injection or dependency inversion of control, that where you configure things in XML files and then don't find out until runtime that you've misspelled something. In Guice, all of your well-known objects, so these are the objects, these are the dependent objects that you care about, are registered in one place called a module. Then when you go and create your objects, you use the Guice API to say sort of, hey, give me an instance of bookstore, and then Guice will be responsible for finding the instance of credit card service and the instance of book inventory that it needs. And so Guice creates all the objects for you. Or injects them into the constructors in the fields. So here is how the Maven dependency looks. Add this to your POM file, and you're ready to use this API. Okay, well, let's take a look at how dependencies are managed without Guice. Here I've got an example of a GUI program, as a swing program, that manages it provides a little UI on top of the bookstore. Okay, and so this is another one of those methods where we sort of work from the bottom up. So, okay, I ultimately want to have my bookstore GUI. Okay, I need to create one of those. And I've used dependency injection, so its dependent objects are injected into the constructors or provided to the constructors. And so it needs a checkout panel. Okay, so here's my checkout panel, which needs an inventory, card service, and a logger. Okay, so here's where I create my logger. Here's where I create my card service. Here's where I create my inventory that are all needed for those guys, and oh yeah, that needs a file, etc., etc. So just to create this object here, okay, I need all of this boilerplate here. Now, it's much better to have this in the main method than it is, let's say, the constructor of checkout panel, right, for the reasons that we talked about in the previous screencasts. But still, this is kind of ugly. I mean, so for instance, if we wanted to introduce another panel, maybe that's not for so much checkout, but for inventory, we would have to pass book inventory to that too, and the code just keeps getting bigger and bigger. All of a sudden, your method is much longer than a page. Instead of having to create all these objects and manage all of this stuff yourself in your own main method, we're going to see an example of how to use Google Guice to manage all of that for you. First, what you need to do is you need to annotate constructors that are to be invoked by Guice, or basically you're telling Guice by annotating a constructor with this @inject annotation, saying, hey, if Guice is going to create an instance of this class, here's the constructor that it should use. And when Guice goes and invokes this constructor, it will then look up the well-known instances of the book inventory interface, the credit card service interface, and the logger that you care about. And the nice thing here is that your code doesn't need to create the dependencies anymore. If you just tell Guice, and we'll see how to do this in a second, it's like, okay, well, this is the book inventory implementation that I want to use, and here is the credit card service implementation that I want to use, here's the logger that I want to use, and you figure out how to wire everything together. Now, you can also use the @inject annotation on methods, and those methods will be invoked right after the class is instantiated, the object is created, or non-final instance fields, and those will be invoked. Those will be filled in. Those will be injected again right after the constructor is invoked. My preference is to make the dependencies more explicit, if you will, by making the parameters to the constructor. It also makes it a little easier to test the code outside of Guice if you need to provide all the dependencies in order to create the object. Note that if you are using the logger, for some reason Guice will control which logger is injected, but any other object you have to use yourself. If you're not using loggers, then you can ignore that. Okay, so this is great. So now instead of having to wire all this stuff together myself, I just sprinkle @inject annotations on the constructors that I want to be injected into. But I also need to tell Guice which implementation to use for a given interface. And the way you do this is in something called a Guice module. So Guice module is a subclass of something called abstract module, and it's got APIs for binding an interface to its implementation. It's kind of like a factory method, but it's sort of like configuring the factory. So here well, I'll see an example of the whole thing in a second. Inside my module, I will invoke methods and say, hey, bind book inventory class to book database. So bind the implementation of book inventory to book database. And so then by telling Guice that, when it needs a book inventory, it's going to use an instance of book database. It'll create all this stuff through reflection. Note that by default, Guice will create a new instance of a bound class whenever it's requested. So if I ask for a book inventory in this constructor, it'll create a new book database. And if I ask for a book inventory someplace else, it'll create a new instance of book database, which in the case of book database you probably don't want to do. You want to have one instance of this shared by all users. So the way you can do that is by making the book database a singleton object. And you have a couple of options in Guice for doing that. You could have the book database itself advertise that it's singleton by annotating the book database's class with @singleton. Or you can configure the fact that it's a singleton inside the module. So when you bind something like credit card service to its implementation, First Bank of PSU, you can say I want to bind it in the singleton scope. And so you can configure it here. But regardless of how you configure it, when Guice sees that you're trying to create a singleton, it will create one instance of it and then use that same instance, will provide that same instance to all of the consumers. There's another annotation that I wanted to cover in Guice, and that's @named. @named lets you identify, well, objects that have a well-known name. So, for instance, the constructor for my First Bank of PSU, it requires, well, a server, a host and a port. And now I don't want to hard code the host and a port in there, because maybe I want to use First Bank of PSU in a testing scenario where maybe I've got like a local, a mock web service to just stub out, or maybe the First Bank of PSU changes the name of its server. I don't have to go into like the deep in the source code to change that. I just want to change that in one place, and so I can use these named objects to do that. And so now when I set it up in my module, what I say is going to bind a string that's been annotated with the server host name, which is the same value up here, to the instance localhost. And this sort of toInstance and annotated with can be used with any type of object. And so similarly, I'm going to bind something of type integer that has been annotated with server port, the name server port, toInstance or toValue 8080. And so now when Juice instantiates the first bank of PSU, it'll provide the values of the server and the host port to this constructor. In addition to having objects that have well-known names, you can also create your own annotations for well-known objects. So for instance, here is an example of a data directory annotation that is used to represent or to instruct Juice, hey, this is the type of the file that's used for the data directory in the, the book database. I think this is the first time that we've seen declaring an annotation, and the syntax is a little different. So oddly enough, there are a bunch of annotations on the annotation. So here's a declaration of an annotation. So instead of just being an interface, it's an at interface. I don't know why they called it at interface. They probably just wanted to reuse a keyword or something. At interface. So public at interface data dictionary. So data dictionary doesn't really have, or at least this one, this particular annotation doesn't have any methods or anything like that. Instead, it's just an annotation, and there are some. It itself is annotated with other annotations that describe what the annotation does. So, for instance, documented, meaning it should show up in Java docs, and at target means what program elements can have this annotation applied to it. So a parameter can be annotated with the data directory, and a field can be annotated with at data directory. We want its retention policy to be runtime, meaning that we want the annotation to be available both at compile time and at runtime. And then finally, there's a Juice specific thing called binding annotation, and that way Juice knows that it should be taken into account when Juice does its magic to create objects. And so you use this annotation on constructor arguments and things like that. So now book database has at inject saying, hey, well, this constructor should be used by Juice to create the book database, and the directory in which the file lives is the at data directory. So when Juice goes to create this book database, it'll use this constructor and say, okay, well, here I'm looking for the file that has been bound to at data directory, and you bind that in the module. So now we bind a file that's been annotated with at data directory to, here's the directory object that we created. It's essentially Java IO temp. It's the temp directory. But anyway, here you can have your application define its own annotations that are used by Juice. So it can be very, well, I hope this is straightforward to say, okay, this is the data directory that we want, the data directory object that we bind into here, that we want to have injected. Okay, so now we've seen all these annotations that you can sprinkle over your code, and we've seen how you can create this module object that binds various objects into various names and interface to an implementation. You can say, hey, something of this string with this name, it should be bound to this object. Here's sort of how you get started in a Juice application. So here's the main. So remember the main method before we used Juice to manage our dependencies, you had to create all of the objects yourself and you had to wire them all together. Well, with Juice you do the following. First of all, you create something called an injector, and you create that around a module, one or more modules. So the module is the thing that sort of defines what the bindings are, and then you provide that module to this thing called an injector. And the injector is the thing that, well, among other things, creates instances, or gets instances in the case of something like a singleton that's only created once. So you say, okay, give me the instance of book inventory. And book inventory, well, the book inventory in the module was bound to the book database. And so Juice will say, I'm looking for a book inventory. Oh, that's bound to the book database. Okay, now I need to create an instance of book database. Oh, look, it's a singleton. I only need to create it once. It's going to look for the book database constructor that was annotated with at inject. It's going to find that one, and then it's going to fill in all of its parameters. As we saw, the book database takes one parameter, the file, which is specified, the directory, which is specified by at data directory, and poof, there you go. But you know what? You don't need to know all of that. All you need to say is, hey, give me the instance of book inventory. And Juice takes care of all of that binding for you. And that's the real power here, to let it manage all of this stuff. It lets you take advantage of the dependency injection, the dependency inversion design pattern without having to worry about all of the wiring. So I go and I get the book inventory. I'm going to add a whole bunch of books to that, just like I did before. Then I'm going to get the instance of the bookstore GUI. And again, it's going to do the same thing where I'll look for constructors that are annotated with that injection and find all the parameters to that. If it can't resolve something, if something hasn't been bound correctly, I'll give you an error message. And actually, the error messages have gotten a lot better in terms of specifics around, okay, what you need to do to fix it or what thing couldn't resolve. So it's really good. So we've gone from like a big ugly method with lots of logic in it and lots of object creation and local variables and stuff to really just sort of two sets of code, one to set up juice, and actually three. One to set up juice, and then get this book inventory to populate it, and then get the GUI and show it. And by the way, somewhere along the line, the bookstore GUI is going to want that same book inventory, and because we annotated with that Singleton, it's only going to get created once. So really what this gets you is code that is more decoupled because, well, you've used dependency injection, you don't have objects creating other dependent objects, everything is passed in, and that has the advantage that objects are more simple and that they can be tested more easily. And Juice also allows you to reconfigure your objects more easily. So if you want a different implementation, just go into your module, find, okay, now I want a different credit card service, go change it in one place, and you don't need to worry about making changes all over the place just to introduce another implementation of an interface. Okay, a couple more Juice things. A couple more juicy things? A couple more Juice things. So most of the time, or at least my preference when using Juice, is to have dependencies injected into constructors, and then have Juice magically create objects transitively by invoking those constructors. This isn't always the case. Sometimes the act of creating an object and configuring it is more complex than what you either can fit in a constructor or want to fit into a constructor. And sometimes you might have dependencies that are not provided by Juice itself, be external dependencies. What we should do in this situation is use something called a provider. So in your module, you can annotate certain methods in your module as @provides, which means that it'll return, the method returns a value that should be paid attention to by Juice. It should be bound into Juice. So here is an example of how instead of just having there in your module, you can have a method called provide data directory. It returns a file. And it does the logic of, okay, getting the location of the temp directory and returning the file. But by annotating with @provides and @data directory, Juice will use reflection to discover this. It'll invoke this method and then take the return value here, this file, and bind it into the Juice context attached to the @data directory. And so the same thing with the first bank of PSU. Having those @name constructor parameters, it was a good example. I don't know if I would actually do it that way. I think it would probably be better to have that instead of having Juice create that one, just have a provider method that creates it instead. Having Juice create it via reflection, have the module specify it via @provides method instead. If you've got even more complex initialization logic, there's something called a provider class that allows you to, that has a get method that will lazily initialize objects, and this is good when something's very expensive. So let's say that you've got, an encryption key, and creating that encryption key is a very expensive operation, so you don't want to do it until it's actually needed. So until I create some object that depends on an encryption key, I don't want to create it. So that's a good point. I don't know if I mentioned this or not, but Juice, when your application starts up, when your main starts up and you create your injector, when you create your injector from your module, it will go create all of the all the dependent objects and wire everything. It'll wire some things. It'll invoke all those provider methods on the module and create it all that way. And that's usually okay, but maybe some things that you want to wait and load them on demand or do it on demand. If for those things, instead of doing it at initialization time, you can do it with a provider here. So here's a class called Encryption Key Provider, which implements a provider of encryption key. And so it's going to have a get method that returns an encryption key that then performs some expensive operation. So let's say the act of creating a new encryption key, that's expensive. This is not real code, it's just example code. Oh, look, this is an object that's also managed by Juice, and so I can have an @inject of the encryption key algorithm, whatever that is. assign it to the field, and then create a new one that way. So in your module, you instruct Juice that instances of encryption key are created by this provider by saying bind encryption key to provider, that class. So here's an example of injecting a provider into an object. Just for the sake of example, I chose to use field injection instead of constructor injection. Here again, my preference is to use constructor injection. Again, the reason you want to use constructor injection is because when you write a unit test for this, it's a private field. I don't know how you're going to initialize this for a unit test. It's much better to pass it into the constructor. But anyway, blah, blah, blah. This is just an example here to show that it can be done. So I've got a key provider here, which is the provider of the encryption key. So at inject, which tells Juice, hey, Juice, I want you to put it in there. Create it, and now let's say I've got some method on my connection manager, which is, hey, go create some connection, and I'll create a connection. You can't see me doing air quotes. A connection with, and connection takes an encryption key. And the way I get an encryption key is by calling the get method of the key provider that was passed in. Well, I guess another important thing to note here is that connection manager itself is a singleton. So even though this guy is only created once and only once, because I use a provider, every time I call get is going to create me a new instance of encryption key, which in this case is what I want it to do. But one of the things you need to be careful about when dealing with singletons is realizing that they're only created once, and that if the state is set, it's only set once. Or if you've got multiple objects, if you've got mutable state in a singleton, which is not something you want to do, if by some unfortunate chance you do have mutable state, state that can be changed, mutable state in a singleton, you might have two objects that depend on it changing that state at the same time and getting surprising results. So what have we learned about? Well, I see dependency injection as really the ultimate expression of programming to the interface. We've talked about it all along, saying, hey, how your methods, let's say you've got a field, don't type the field of type array list, type it as a list and then deal with it abstractly. Well, this sort of takes it a step further as saying, hey, I've got some object that depends on something else. I don't know what that object is. I don't care what object it is. I just care what contract it provides me. Dependency injection encourages the Hollywood principle. It states objects should have their dependencies delivered to them upon instruction instead of creating them themselves. What the dependency injection design pattern does for you is it decouples your objects so you can have finer grained testing. So you don't need to create as many objects, do as much setup in order to test them. Now we saw an example of a framework called Mockito that provides facilities for mocking objects, so that you can use these mock objects in your test. So the dependencies of the code under test can be expressed using mock objects that can be then configured to behave how you want them to behave for your test. Google Guice is a library that your application can use to manage dependencies by separating configuration code from application code. All the configuration code is in the module, and then the application code itself is just plain old Java code with, yes, maybe some Guice-specific annotations sprinkled over it. Then Guice does all of the wiring for you, and you don't have to worry about that logic. Okay, well, hope you've enjoyed talking about dependency injection. As always, thanks for watching the screencast for Advanced Java Programming at Portland State University.